local bias. All right, so let's talk about orphan ports here. Orphan ports, there was a question about it, are ports connected to a single chassis. So there, no floating IP or ARP load balancing. So we do not support that feature in this mode. Asymmetric traffic will use local bias disable. So that's important. You will disable the local bias by default. So that means that, for example, if you have defined a virtual router, I mean, we call them logical router now, on one firewall only, and then the packet ingress here, the local bias will be disabled. It will egress to the same firewall, even if the flow is owned by the neighbor. Refer to the state machine on the previous slide. But by default, local bias is disabled for orphan port. In order for you to maintain your redundancy on orphan port, we support graceful restart, right? Because don't forget, from the management standpoint and the control plane standpoint, this is an active-passive system. The standby or the follower, we call it, will take over if you have a failure on one of the chassis. Okay. All right. So one kind of the migration strategy, I like to call it migration strategy, but let's go over what we have today with HA on your generation 3. And then let's see what the advantage of the next generation firewall clustering is compared to those solutions. So in classic layer 3 mode, where the firewall is in layer 3 mode and peer, let's say, I'll take an example here of a data center fabric, and we are at the edge of that data center fabric. We do eBGP peering, and of course we are in active mode, and we are facing the PE from the service provider, and then on the other side we're facing a service leaf from the data center. So dual control plane on active, right? Legacy active has control plane independent from each other. Multipathing, if you want to do multipathing, you have to rely on ECMP, which limits you to 4 paths, right? That's the current limit we support. Yes, it has the advantage that you can support bursts of traffic beyond the single system capacity, and that is the main advantage of active, and that's why our customer likes it. Also, if you fail over, the sessions that were on the surviving member will be layer 7 inspected. All right, only you default to layer 4 inspection on the session that were owned by the failing member. We do not support fragment reassembly on the HA. And the traffic over the HA tree must exit on the other member. So that means that local bias is always enabled. We cannot disable it. If there is no next hop, the FIB is full. I have quite a few escalation like that, where the owner received a packet from the other device, from the active secondary. For example, the active primary is the owner. He received a return flow from the active secondary, perform the layer 7 inspection, then pass it to the routing engine, and the routing engine say, I don't have a valid next hop for this, and he drops it. Of course, he logs it and all of that, but still, you have broken the forwarding rule. It could have sent it back. IPsec is synchronized with floating IP. I mentioned that earlier. That consumes a lot of IP address because of the floating IP. It's one on each chassis plus the virtual one, and then you terminate on that plus the one of the IPsec tunnel. That's 4 IP address per tunnel. It's quite a lot of IP address. IP address are not synchronized, of course. You have to do it through Panorama if you want to do that, because they must be different. They belong to different routing engine. NAT table are independent. So what does that mean? I mean that if you wanted to have the same type of translation between the two members, you have to overlap your pool or manage your pool or carve out your pool so that, you know, when the traffic ingress on the firewall, you have the same type of NAT translation, right? If you fail one member, your pool is still reduced because you share between the two. The same pool is shared now between two control plane. So it's a little bit more complex to set up. You have to pay attention, and you have maybe less availability, right? So what a lot of our customers, I realize, are doing in order to avoid a lot of those problems necessarily, that It's difficult to manage. Traffic may be unpredictable and things like that. What they do, there's a feature that we say you ping session owner, session setup to primary device. And at that point, if you do that, what you do is essentially transform your active-active into an active-passive, with the HA tree being heavily used for asymmetric traffic. Now, moving on to the active-passive legacy HA, this has a single routing engine, of course. The other one is fully synchronized, but silent. And you use BFD and graceful restart to minimize the switchover time. And actually, this is 90% of our deployment, according to our AI ops. We can see what customers are deploying in general, and that data showed us that active-passive the preferred choice. We can unfortunately not sustain a burst of traffic beyond a single system capacity, and that's normal. The second one is totally silent. All sessions are layer 4 inspected upon failover, right? Because the standby does not have any ownership of traffic. It's not in line with the data plane. IPsec synchronized with the loopback. That's a big advantage. You consume less IP address. And we do IPsec kind of failover by maintaining a IK phase 2 synchronized, but not IK phase 1. So your tunnel will go down, but can rebound very quickly. It's simple to manage, and that's probably the main reason why it's heavily deployed. It's very easy to manage, and the synchronization of the config is fully done. So there's way more items the config is synchronized, so it's easy. And that pool is synchronized, so that means you have a single pool. When you switch over, you don't have to manage the pool like it is the case in active-active. So now let's look in the layer 3 peering what the layer 3 clustering bring you to the table. Yes, it's a single routing engine, so active at any time. So you rely on BFD and graceful restart to minimize switchover time. We have done some measurement. You switch over by, if you remove the MPC, so the management processor card, we switch over in less than 5 seconds. While this is happening and we converge, we use graceful restart. We lost a very little amount of traffic because graceful restart keep the FIB forwarding at that point in time. However, the convergence take a little bit longer. The redundant peering over a single IP address, no more floating IP, so your IPsec tunnel can be terminated on a loopback. In this case, so you consume way less IP addresses, right? MCLAG to provide you an extra layer of resiliency while increasing your capacity up to 16 paths, and a fast failover in the case of link failure, right? And if you do, like illustrated here, a full cross connect, you guarantee a double failure before having an impact on your network. We can go beyond the system capacity. We have done testing. We can do close to 3 terabits per second of app ID in cluster mode when traffic is perfectly symmetric. You need to have perfectly symmetric traffic. Then we can go beyond the 1.5 tera of a single system capacity. We have a layer 7 inspection at all costs. We want to keep your data protected. That's why layer 7 inspection is paramount here. And that's why we can disable the local bias and not drop the traffic, maintaining layer 7 inspection, right? HSCI is now supporting MACsec. So also simplify your layout. You cannot use DP port for the interconnect, only the HSCI of the management, the MPC, the management module. And there, and we do that because we want to minimize the delay, the jitter, and all of that. So they are very, very, very tightly clustered. With MACsec, you are FIPS 140 compliant, also for security. Right? If you do a failover, the session that are, let's say you lose the leader, the follower takes over. All of the sessions that are on the follower will be maintained layer 7 inspected. Of course, the session that are on the failing member lose the layer 7 inspection and will default to layer 4. But that is expected. We are a stateful device. If you lose your point of deep packet inspections, we cannot move that data across. NAT table are synchronized. No need to split your NAT table into a sub pool. You create one pool. When you fail over, the NAT table is synchronized. You keep translation, right? And fragment are reassembled through a mechanism of virtual buffer inside these new solutions. Yes, so this is a good question. So how are updates and reboots treated to maintain redundancy and inspection? I think I just went over very quickly. If you lose let's say the leader, all of the sessions that are inspected by the leader will be layer 4 inspected on the follower, which become the remaining member of your cluster. That's how it is. We recommend that if you perform an upgrade, and I have done one Friday to go to 11.1.5, which is the latest version, go the follower route. It will tell you through who is the follower. Go on the follower, upgrade the follower, and then if you upgrade the follower, there is no switchover. The leader maintain his control plane active. When you finish rebooting the follower, move on to the leader. We support synchronization within the same version. So there would be the system keep being synchronized both to each other and through Panorama if you do that. And then you can upgrade your leader. And finally, that leader will reboot. While you reboot, the follower will become the leader, and then you can regain. You have your cluster in sync again. So this is for L3. So let's see quickly over what do we have.
Patrick, sorry to interrupt there. There was a question there from John Joseph about.
I missed that one.
I'll let you just read that one instead of trying to say it.
That is a virtual router question. So on 12.2, you're still in the okay, versus even for. That seems like a support case for me, that you seems to have an issue where you have upgraded from 10.2.9, John Joseph, to 11.1 to 11.14, and then or 11.1.4, I suppose. And then you have an issue with ECMP. Can you follow up with me on that after the call? I mean, this require a discussion by itself. Is that okay? You can reach out.
Yeah, I'll be posting a link in the event in the chat a little bit. We do have a discussion location in live community to talk about this event afterwards. So any communication that you'd like to have afterwards, you can just take it up in there. I'll post the link right now actually for that.
Okay. All right. Yeah, I can follow up with that. I prefer you have a tag case open, so that's easier for me to interact with you through a tag case. Let's look at the failure case here of the MC-like. Let's imagine now, you remember this complex decision diagram that I show you. Let's see it in practice. Traffic inbound on the left firewall. Firewall A on the left is become the flow owner. Then the traffic, for some reason, to routing become asymmetric and go back on firewall B on the right side. And then at this point, he realized that both links leading to the PE are now broken. It cannot perform a rewrite. Then he will say, okay, so I have no way to send this traffic. I'm going to trombone. We call it the process tromboning the traffic. It looks like a musical instrument. And then we send it over firewall B, where firewall B will perform the final rewrite if available, and then forward the traffic. If he's not able to perform the rewrite because the next hop is no longer available for whatever reason, then he will drop the traffic, but that is normal. If you think about routing, that's how routers do. It does not drop it on the neighbor device. It drop it on the device it was received because it does not have a route to that destination, unfortunately for him. The traffic came correctly However, it does not have a destination back to the source, and you would drop it. So that is the correct way of doing routing while maintaining layer 7 inspection at all cost. We can talk about vWire mode. So vWire mode, don't forget, we do support MC lag in vWire mode. We do not recommend it because, sorry, if you do MC lag in vWire mode, you can have your LACP packet take different path, and suddenly one port is neighbor to 4 or 3, depending on the way it's hashing at layer 2. So, but you can maintain your vWire on a single port, and I think we recommend that. Now, what is the advantage of our solution is that you can create an MC lag on the neighboring device, whether it's an Arista or a Cisco. We have tested the solutions with both vendor, and we keep testing it actually with both vendor. So you can do and then create a 4-port aggregate on each side and have individual ports on the active in this case there. So we're not going to change a lot from this concept in vWire, but there is a few things that we introduce. So don't forget, in active, legacy active, you need the redundancy, because you're in vWire mode, is through the BFD, but on the third-party device, not on ours. You can use link and path monitoring for failover detection. This is the case where even in vWire mode, HA, we do disable local bias. So scan packet must be returned to the receiving firewall to preserve the forwarding path. And that's normal because it's a pipe. You cannot leak traffic from a pipe. So then the traffic returns back to the pipe. If the owner is on the firewall on the left and the return traffic come through the aggregate Ethernet here, come on the right, it will go back to the DP owner and come back to us because it needs to go back in the pipe, right? So this is local bias disable is the only case where you will see it on a legacy HA, right? It's not in layer 3. It's only in legacy HA. So for active-passive, not much to say here. Of course, now you can no longer create your full MC lag or VPC on the neighboring device. You could, but then half of your link are down and things like that. And it's not recommended because we have this feature where we maintain the layer 1 active, but we do not maintain the layer 2. So to accelerate the failover, so you can, we usually recommend is you create 2 MC lag, one from VPC1 and one for VPC2, let's say, if we use a Cisco terminology, and then we maintain a single port for ingress and egress on each firewall, right? So what do we bring with the clustering? Same thing as active without the overhead of active. We do perform local bias disable because now the feature is becoming more orthogonal with all of the type of flow. We have link and path monitoring. We send, of course, the traffic back to the origin. That's mandatory, right? So we do that. And it's pretty much the same as active at this point. You can configure your third-party device with a full port, in this case, MC lag or VPC if you want to. So simplifying your topology, if you want to mix vWire and layer 3 in the same device, you want to do that through multiple VSys. By the way, VSys is going to be supported in 11.1.8, so the system supports a single VSys at this point. We will do support multiple VSys at the subinterface level in 11.1.8. It's currently under test. And then at that point, you can create one VSys, have all your vWire there, and another VSys, you want to have all of your layer 3, or you want to mix and match within a single VSys, vWire and L3. You have the advantage of active for the vWire. You have the advantage of an active-passive. and active-active in layer 3 mode. The solution is, of course, as you can see, way centered around L3, which is the vast majority of our deployment. Well, and I'm going to conclude here with two things that I would like you to take away with you. A firewall. We are the fastest firewall in this market. 1.5 terabit of app-aware performance inspection. If you do layer 7 inspection, you can do 1.4. That's the maximum capacity with a fully loaded chassis. If you want to do threat inspections and SSL decryption, the performance degrade to close to 400 gig, 390 gig per second. You can have 440 million sessions per concurrent at the same time. The system support up to 2 billion. So that's why we have the clustering, right? That's because you need to synchronize the session across multiple chassis. We have a huge provision of session. We can extend these solutions to more than 2 nodes. Right now, we are doing it on 2 nodes. We want to make sure it's stable, and we want to make sure that it's resilient and all of that. Once we are certain, we're going to extend that with upcoming platform up to 4 nodes in the cluster. Right, so you can support up to 9 cards in one chassis. You need a management card, right? You need also a data processing card, so you can mix and match. If you want to do very light inspections but a lot of traffic, you can fully load your chassis with 7 networking cards and 1 data processing card. You want to maximize your traffic inspection and reduce the amount of traffic. You would put a maximum of DPC card and a relatively minimum of networking card, right? When you do clustering, you have the advantage of active-passive for the simplicity of configuration, the simplicity of management, and you have the advantage of an active-active by leveraging both chassis forwarding capacity at the same time. You have the extra advantage of MC lag, allowing you to create up to 8 paths, at this point 16 in the future, redundant path across the systems. Simplification, no more HA1, HA2, HA3, a single HACI, 400 gig, that interconnect the 2 chassis. And I can do a quick overview of the chassis if we have time. I don't know, Charles, if because I have another session coming after this one to present you the advanced routing engine. But if you want, I can spend a little bit of time to show you.
If you have a few minutes, please feel free. Absolutely, yes.
Okay. Unfortunately, I've been locked out. 1 second.
Yeah, while he gets ready, anyone, if you do have any further questions, please feel free to throw them in the chat. Again, after we do this quick little demo, we'll take a 10-minute break, and then we'll go into the advanced routing engine, the ARE, after we're back from that little 10-minute siesta we can all take. But as always, if there is anything Fuel can do for you, if you want information on chapters, if you want information on future events, topic suggestions, please feel free to reach out to us, fuel@fuelusergroup.org. We're here very literally for you. So whatever we can do there, please let us know. All right, all yours, sir.
All right. So here we go. We have panorama. I hope you can read it.
Yeah, can you zoom in just a little bit more, I'd say?
Like
that
this.
Should be good, sir. Cool. Thank you.
Perfect. Right. So, of course, this. So let's quickly look over the dashboard. I'm running versions of Panorama 11.15 here, which has the clustering. You clearly see here, I have activated the cluster plugin. This is how you configure the cluster. You see that I have 2 member, 2 7500, completely in sync and online on this one. So this one I just rebooted this morning, so probably no status is unknown, but let's see if it has finished. No, it's still unknown. I'm still rebooting them so when you want to manage the cluster, you see clearly here, you select them in order to join the cluster. You see the node ID being proposed here. You can change that during the creation of the cluster, and the node ID is directly associated with the serial number. Don't look at the serial number. This is a beta device. The serial number is weird. This is not for production. This is for me in my lab here in Santa Clara. The communication here is done by, this is where you're going to define your IPsec, your MACsec profile. So there is a new, you can do it here. There is a new profile that you have to create to support MACsec. And here is your monitoring state. So you remember when I presented you the local bias, right? And all this diagram, you have the capacity to do, to configure the behavior of your system depending on how it get degraded, right? If you lose capacity on one member, you have a choice to perform a switchover or keep working but in degraded mode and maintain your local bias, right? So if you wanted to, and you can define the level at which you're going to fail over. This is new with this solution. And why are we doing this? Because we have realized that some customers want to maintain, do not switch over because they don't want to pay the cost of the switchover in terms of data loss. And they don't have a lot of traffic anyway, so they say, okay, you can work in degraded mode, that's fine. I have redundancy in my chassis to handle enough capacity remaining in my chassis to handle the traffic. But other people say, no. If a system get degraded, I want to switch over. I want to switch over because I don't know how the degradation is going to happen, what kind of implication. I want to be deterministic, I switch over. You can define the minimum amount of a networking card or a data processing card that is required in order, below that minimum amount, the system will fail over. So this is the configuration from the, all right. So from the plugin into Panorama, you will have to go and create for MACsec. You will have to create your MACsec profile. Sorry, and this is, I think, here. Here, don't forget MACsec support AES 128 and AES 256 in GCM. So that's the only two possibility. That's where you're going to define your, confidentially offset. So the confidentially offset is the amount of time that we allow an expired key, MACsec using symmetric key, but we allow a key to be accepted before we refused it. And then, of course, your rekey interval and your anti-replay window. So this is traditional configuration for MACsec. And that's what you're going to apply. MACsec is not available on your front panel port. I have that question quite often. No, as right now, it's dedicated for the clustering solution only. Once you have configured, you can clearly see here, I have configured 2 different AE that are in MC-like mode. You clearly see, for example, node 1, Ethernet 1, and oops, sorry. All right, cancel. Node 1, Ethernet 1, and Node 2, Ethernet 1 are part of the same AE. Right? And then here at this AE level, I have defined this interface as a layer 3. And I have defined my logical router associated with it, which is LR1 here. Now, if you look at 1/2 and on node 1 and 1/2 on node 2 are part of the second MC-LAC AE2, and AE2 is in virtual wire mode. So like I said, you can use them in vWire mode or in layer 3 mode as much as you want. When you are in AE mode, we do not change anything. Panorama will allow you to configure it either in virtual router and logical router mode. So we do not support virtual router mode in with the 7500, but Panorama does not know that. So he proposed you both. You have to use the logical router, and then we're going to talk about it in the next session. And then, of course, it's just like a regular interface. You can enable LACP if you want for the AE. Sorry, either in active or passive mode. We recommend you using active mode, so for a faster convergence. And the system priority is what you decide you want to do, if you want it to be the primary active, or if you want it to be the secondary active in the LACP negotiation with the third party. So as you can see, this from the configuration standpoint, this is equivalent to a regular interface. You don't have to change anything. Once you have defined your node interface belonging to a specific AE, the rest is just an AE configuration. There's nothing special about it. And that is the advantage of our solution while maintaining. So for example, how do you do this when you want to add an interface? In this case, don't forget all of my template and template stack. Hard cluster enable, you will have to select the node ID in which you wanted to attribute the card. Let's see, node 1. You have to select your slot. In this case, I have only slot 1 available in the system, and then you can choose the interface. The next free interface that has not been assigned yet is 1/4. Then, of course, you define the type of that interface, and you see here we propose aggregate Ethernet layer 3. If you do just layer 3 or layer 2, you will be in orphan mode here. If you choose aggregate Ethernet, and then you can do that. If you want, you can put that aggregate Ethernet. You can decide to have an aggregate on a single system if you want to. We do not remove that capability for you. That still exists, but it will be what we call an orphan aggregate rather than a full aggregate. And then you have to choose, the aggregate group here. So first, create the aggregate group, of course, that you need to have. That's just really briefly how you configure the cluster. I just wanted to give you just a little bit of an overview of how to do this. When you define your MCLAG, once again, there is nothing that is different. You do it in a layer 3 mode. Do not forget, only logical router will be available here. I only have created one logical router. Assign the zone, of course. Put your IP address here, v4, v6. Enable LACP if you want to. And of course, you have just regular thing. It's just that when you, okay, I already created that object. Okay, it's just that this is just standard configuration. From your operational perspective, this does not create a major change, but bring several advantage in terms of flexibility, forwarding capacity, and we went so much over it already. Well, that is pretty much the conclusion I wanted to leave you with. Unless you have other question, I'm gonna stop here. I think I'm just about over time, so I don't know if I can answer the question during the pause, but feel free. Since I'm the second presenter, also I will be answering them.
Yeah, not a problem. Yeah, tell you what, let's actually, if we can, everyone, let's, instead of a 10-minute break, let's just do a 5-minute break if we could, because I know we want to get right onto the next section, and I know we're running a little bit over on time, but this stuff is fantastic, and I think everyone's going to be looking forward to the advanced routing engine presentation Patrick's going to give in a few. So let's go ahead and take a 5-minute break right now. I'm in Central Time, so it's 12:47, so 12:52, 52 minutes after the hour. Let's come back, and we'll see everybody in just a couple minutes. And Patrick, if you just release screen for me, I'll just throw a break screen here for a quick moment.
I'm sorry?
Yeah, just stop sharing for a moment if you would.
Of course.
Yep. We'll go ahead and just share out this guy. And even though it says 10 minutes, it's actually only 5. So we'll see everybody in about 5 minutes. Okay, thank you.